For decades, developing nations faced a brutal mathematical reality. Lowering carbon emissions meant turning down the dials on industrial output, directly crippling economic growth. In this video, we see the scale of that exact tension in India. The nation requires massive industrial expansion to lift its population into the middle class, while simultaneously committing to strictly enforced net zero targets. Fueling that rapid expansion currently requires a massive influx of energy. Because domestic supply cannot meet the demand, that energy largely comes from expensive imported fossil fuels. That creates an immediate economic trap. Slowing down factory production hurts domestic prosperity, but maintaining the current trajectory forces the country into an increasingly severe dependency on foreign energy markets. Escaping that trap requires breaking the old rules of industrialization. To survive, the manufacturing sector has to figure out a method to produce smarter, completely severing the link between energy consumption and imported coal or oil. Solving the climate crisis here moves past basic damage control. It is the primary blueprint for a new kind of industrial growth. This redesign is called industrial reinvention. Engineers are moving away from the view of carbon as toxic waste, instead treating captured emissions as a valuable raw material. In this system, the dark industrial emissions are physically intercepted at the source. They are pulled directly from the smokestack into specialized intake architecture before a single molecule can reach the open atmosphere. Once captured, that trapped carbon becomes a strategic industrial input. This rewrites the financial calculus for heavy manufacturing, because factories can suddenly create tangible economic value out of the very emissions they used to pay fines to release. As this diagram illustrates, a single captured carbon molecule can be routed into 3 profitable new pathways. It can be synthesized into carbon to fuels, converted into carbon to chemicals, or embedded into solid carbon-based industrial materials. Adopting this circular carbon mindset changes the global climate narrative. Decarbonizing heavy industry becomes an avenue to improve project economics and secure a lasting industrial advantage. Domestic climate technology companies are currently building this exact infrastructure on the ground. A prime example is Biogenic Urja, an engineering firm designing the systems that actually convert captured emissions into usable products. But turning a raw greenhouse gas into a valuable commodity requires immense amounts of energy. The core technical challenge is finding a specialized catalyst to force that chemical reaction without simply burning more fossil fuels in the process. The solution is green hydrogen. This is a highly combustible, clean molecule generated without emissions, which can power these smarter factories and drive the necessary chemical conversions. Biogenic Urja's mechanism uses renewable energy to separate water, generating green hydrogen. This hydrogen merges with captured industrial carbon, synthesizing into a refined liquid fuel. Finally, the system routes this clean fuel back to power the original industries, closing the loop. The physical result is a modernized, high-tech factory that can operate continuously and at maximum capacity, with zero visible smoke leaving the facility. By utilizing carbon, Biogenic Urja's technology proves that heavily polluting sectors can morph into self-sustaining ecosystems. They generate their own clean fuel supply on-site, vastly improving their long-term project economics. Scaling this closed-loop technology outward from individual factories to the macroeconomic level has a direct impact on national trade vulnerabilities. In this footage, motionless Carter ships illustrate what happens when a nation scales up domestic low-carbon manufacturing. The immediate requirement to ship massive volumes of foreign fossil fuels across the ocean simply vanishes. Replacing those imported fuels with locally synthesized alternatives translates directly into absolute national energy security. The country is no longer subject to the price shocks of global oil markets. This is climate self-reliance. This strategy elevates domestic climate technology to a critical sovereign capability project, specifically designed to insulate and protect the national economy. India's net zero journey requires no economic sacrifice. By utilizing carbon instead of running from it, the transition provides a strategy for industrial modernity and total energy independence.